My name is Fahad Farooq, and I'm taking care of well construction site, primarily for drilling bits and drilling fluids in Pakistan. My apologies once again for being a little bit late. Right now I'm in Oman, so I got a little bit confused about the timing itself. So once again, welcome to all of each and everyone for attending this lecture. It will be a good opportunity, a very good opportunity, learning opportunity for everyone for about the topic today, which primarily covers the diversion technique with temporary isolation on demand to stimulate multiple zones. Our distinguished lecturer is Mr. Haris Siddiqui. He's been working as a fracturing production engineer with Schlumberger, assigned in Pakistan. He has a very diverse experience of working in multiple countries, covering multiple clients, from IOCs to NOCs and private clients that are working in this area, especially in Pakistan, in UAE, and other Middle East area. Haris is a graduate, engineering graduate from Harriet White University, and he has done in BE Mechanical Engineering from NED Karachi. So now I will hand over the floor to Haris so he can take us through. And in the meanwhile, if you have any questions, you guys are more than welcome to ask, or we will have a question and answer session with our lecturer at the end of the presentation. So Haris, over to you.
Thank you, Fahad. Good evening, everyone. Yes, you guys can see my screen.
Yes, very well.
Okay. So let me start by giving a brief overview about the topic. So it's diversion technique, providing the temporary isolation with on demand to stimulate the multiple fracturing zones. So basically, we'll talk about different mechanisms that we have in place and in area that are commonly in use with respect to the completions regarding the conventional and unconventional wells. And then we will go through I will talk about this diversion technique specifically. This is basically a chemical diverter that we have used and introduced in Pakistan to stimulate multiple perforated zones without the need of any workover rig or any other workover facilities that might be required in normal cases, in normal completions. So we'll start with explaining what is basically shale or tight gas reservoirs. So basically, we all know that in conventional reservoir, mostly there won't be a need of doing the hydraulic fracturing. Normally, the wells produced in a conventional wells due to the difference of the pressures. So what basically are the shales or the tight gas reservoir? Shales can be classified as low permeability formation. Normally, it's classified as having a permeability of less than 0.1 millidarcy. It could be consolidated formations, and shales can be in sandstone or carbonates, both of them. Basically, shale is any reservoir that will not produce at economical rates by the conventional completion methods. So we need to use different techniques, which also include hydraulic fracturing as one of the methods. So as we are talking about the shale and tight gas reservoir, so let's talk about the permeability. What happens when the permeability of the formation is low? Basically, we cannot use the conventional completion method in that case to produce the well economically, which is the main criteria for any operator. So we need to enhance the reservoir contact area. That is the main element in this case. It could be done by multiple methods. We'll talk about it like horizontal wells, in vertical wells, how is the contact area in the vertical well, how we are increasing the contact area in the horizontal wells, and what how we can enhance the formation reservoir potential by doing the hydraulic fracturing. Let's go back to the procedure of what hydraulic fracturing is and how we do it and what we are trying to do by doing the hydraulic fracturing. So basically, these are the self-explanatory pictures that I have in my slide. So initially, we will initiate a hydraulic fracture in any formation by pumping a fluid at a high pressure. And then to propagate that fracture, to make sure that the fracture will remain open, we will basically pump the propant. Propant is basically a sand or a ceramic material that we need to pump in the formation to keep the fractures open. Basically, if we leave the fracture without the propant, then the fracture with the time and with the tectonics and all the movement of the earth, it will somehow rearrange itself, and there will be no fracture. So basically, that's the main purpose of placing the propant inside. To place the propant, we have a fluid as a carrier to move the propant from the surface to the reservoir. And finally, we need to flow back that carrier fluid as well, which is one of the important phenomena in hydraulic fracturing. Now, why we do the hydraulic fracturing treatment? We could have, or the operator could have multiple options or multiple things that could be done. Some of them are here. One of them is to bypass the damage that we have and to increase the production of this well, to increase the drainage radius, or to connect the natural fracture network that we already have. It might be that the reservoir or the reservoir or the formation from which we are trying to produce is not connected basically to the fracture network or to the main reservoir, and there are some issues. So hydraulic fracturing might be used in that case, or to connect different layers in the formation. Now, if we are talking about the reservoir contact area, let's talk about the horizontal well as well. So basically, if we see that in the vertical well, let's suppose this is our target formation that we are seeing with a dark color. In the vertical case, the only area that is exposed is limited to the perforated section that we will have in the vertical section. While for the horizontal lateral, basically the lateral will go and we will place the lateral such that a big amount of reservoir. So we are increasing basically the contact area in the horizontal lateral. And in this case, the hydraulic fracturing in the vertical case will only be done for a single stage and only a limited area will be covered. While in the horizontal lateral, we can perform multiple zones and multiple fracturing to increase the reservoir contact area of this lateral and to enhance the production conductivity, which is our prime objective. So this is how it's being done. So basically, if we don't have any specific completion in place for a horizontal lateral, what will happen is that when we pump the fluid in the formation, it will go basically it will take the path which have the very least resistance. So this is the natural phenomenon that it will go there where it will have least resistance. So we can see that here we have like 3 perforation sets, and we are seeing that one of the fractures or one of the zones, perforated zone, is taking more fluid as compared to the other. So to optimize this, or to make sure that we don't have such scenarios, to make sure that we have optimized and to increase the efficiency of this one, we have the completions. So different type of completions are there, and then we have the other methods as well, which are some chemical methods or the other diversion methods that we will talk about it today. Commonly used techniques that we have in the area include the plug and perf. Then we have ball activated completion system, and then we have coil tubing activated completion system. So we will talk about them briefly on each of them, and then we will come back to what we have introduced with the chemical diversion and what is the differences between these and the one that we are talking about today. So let's consider a horizontal well which is ready to be completed. So this is a horizontal well which is ready to be completed. It's a cased hole cemented well. Once the cement is done, we will wait on the cement to make sure that it's hardened. Once it's done, we can move the rig. We can perform this hydraulic fracturing operation rigless. And so basically, once the well is cemented, we don't have any access. To regain the access to the formation, we will run the coil tubing in the well bore with the perforation gun, and then we perform the perforation for the first stage. First stage of hydraulic fracturing. Let's assume we have a cased hole with a lateral in place, and then we will perform the perforation operation with the help of coil tubing. So now with the perforations, we regained access to this formation. Once we have the access to the formation, we can pump the hydraulic fracturing by pressure pumping unit. We will rig up the pressure pumping unit and start pumping our first stage hydraulic fracturing. Once the hydraulic is done, we will pull out this. So basically, we have now created the fracture in perforation for stage 1. Then we will run the wire line to place the plug. So wire line assembly is run with the plug, and then we will place the plug after stage 1 at the bottom with a setting tool. Once the plug is set, we will pull back the wire line. Again, we will carry on with the same phenomena of run in a hole with the coil tubing, do the second set of perforations, pull out, start pumping stage 2 for hydraulic fracturing. Again, we'll go with wire line, place another plug, and so on. So in this method, we can perform as many number of stages of hydraulic fracturing as we want, depending on the reservoir conditions, production, and what is our objective. So that's how the plug and perf technique works. Coming back to the second technique that we have is the basically ball activated completion system. So again, let's consider a horizontal well which is drilled and completed. Here we can have two type of open hole packers. So basically, one of them is a hydraulic packer and the other one is fluid activated packers. So let's talk about the fluid activated packers. So we have a ball activated sleeves there, and then we have a casing packer at the end of the vertical section from where our lateral starts to kick in, and we have open hole packers which are fluid activated. So initially we will give this packer pressure to make sure that the casing packer is done, and then we will pump the fluid to activate the fluid activated packers to perform the seal in the cased hole. Once we have the sealing in place from all the packers, we will start by pumping in the first ball, which will go here to the sleeve 1. Once the ball is in place and the first sleeve is open, we can start pumping the first stage of hydraulic fracturing by rigging up our pressure pumping unit, and then so this is how the first stage will be done. Once it's done, in the tail end of the first stage, you will drop another ball. So with the second ball, your first stage will be sealed and your second sleeve will open with this ball. So that's how the sleeve mechanism will work. Let me explain a bit about this sleeve and ball mechanism in detail. So basically, this is a sleeve and this is the ball. Once we drop the ball, this ball will with our pumping of the fluid, this ball will go to this seat. It will move this seat on the side, and with this we have an open area and access to the formation in this way. So regarding the diameter of the ball, the diameter of the ball is basically increasing from toe to the heel. So at the toe we have the least diameter of the ball, and at the heel we have the largest one. So this is how we know that which stage we are fracturing, or in case we need to skip or we don't get breakdown or we don't get any issue with the completion, we can pump that ball of the certain diameter and then move forward. This is how the ball activated completion mechanism works. Now coming to the third one, coil tubing activated completion system. Again, we'll consider this horizontal cemented well with a casing in place. So coil tubing activated system is basically works with two types. One is with the presence of sleeves, and the other one is with sand jet perforator. So we have a coil tubing in place. We rig up the coil tubing. Coil tubing assembly will include the sand jet perforator and the coil tubing packer. We can see it here. So this is the sand jet perforator in pink, and this is the coil tubing packer. So we'll run in hole the coil tubing assembly. Then we'll set the packer at a specific depth in the horizontal section, and by the help of sand jet perforator, we will pump the sand to make the perforations. Once the perforation are done, we will then start pumping the hydraulic fracturing for certain stage. It could be for stage 1. Let's assume stage 1. So we will be pumping Once the perforations are done with the sand jet perforator, we will start by pumping in the annulus of this one and create a hydraulic and pump the fracturing for the stage 1. Once it's done, we will unset the packer, pull the coil tubing to the second stage to our desired depth, and we'll pump the perforations for the second stage. And the same way, once it's done, we will start pumping with the pressure pumping unit in the annulus of this to pump the fracturing for stage 2. So in this way, we are going to do this coil tubing activated system works in this way with the sand jet perforator. With the presence of sleeve, there is a slight change in this one. The coil tubing assembly will remain the same, but we will have the sleeves in place. So once we have the sleeve in place, now we have a specific depth to do the hydraulic fracturing stages. So basically, in this case, we have a benefit that we can change the fracturing stage at any point, but in this one we have a limitation that we will only be pumping where we have a sleeve. So that's how the coil tubing activated system work. Moving forward to the benefits of each of them. So in the plug and perf, basically we can have unlimited number of stages, and we can increase and decrease. So there is a flexible placement of stages in this technique. We can have the contingency options as well, as the diameter is not restricted as compared to the others, in which your coil tubing will be inside, or in the ball activated, as we have seen that there will be a sleeve, and there is a restriction of certain diameters for the balls. Since the diameter of the ball is decreasing from heel to toe, so that's how it is. So there is, in this one, the efficiency of frag is not very high. So there is some lack of efficiency in plug and perf. And again, at the end of your hydraulic fracturing, you need to mill out each plug one by one to start and put the well on production. Now we'll talk about the benefits of ball activated completion system. So we theoretically have a limited number of stages due to the presence of sleeves. Again, the stage placement is fixed in this one because we have a fixed number of sleeves, and then the contingencies are limited due to the diameter restrictions. The only benefit here is that we only need the pressure pumping unit. We don't need the coil tubing or wild line in this case. Coil tubing activated system with sand jet perforator and frag sleeve. The benefit of that in this one is that we have unlimited number of stages. You can use the sand jet perforator to basically move and do your perforations anywhere, wherever we want. I mean, since we have the sand jet perforator in place, even in the case of sleeve, we can do the perforation in between them as well, and then we can place the stage there. So the advantage is that we don't need to mill out the frag plugs, but again, in terms of refracturing operation, it's limited. With this one, we cannot use this in the refracturing stuff, and then the contingency options are available because we have a full ID available for the coil tubing which is inside the well. This is basically a summary of all the three types that we have talked right now: plug and perf, ball activated, and coil tubing activated completions. So this is all the stuff that we have already talked about. So again, the choice of these completions will depend upon the several factors. I mean, it will be it depend upon, it varies operator to operator. It varies with the formations and the objectives that we have regarding the production. So let's talk about what happens historically, or what normally happens in our region. So basically, if I talk about Pakistan specifically, what we are doing in hydraulic fracturing is that mostly the wells that are being fracked in Pakistan are new wells. Most of the time they are new wells. They are completed with 3.5 inch or 4.5 inch completions. Mostly we have vertical wells, so we are doing hydraulic fracturing on vertical well, and mostly it's a single stage, or where we have dual stage, it's normally two stages. So this is a typical well that I am talking about, which is completed with a 7 inch liner, 3.5 inch completion, we are assuming that it's a new well, so let's assume that it's just drilled. So we have a two zone reservoir section here. Uh, I'm showing this perforation set here, this and this. So basically we have a two perforation sets here. So what we do is basically we will normally the stress profile of these two are not the same. I mean it's different. So what we do basically we put only one perforation initially since it's a new well. So the well is drilled. We put one of the perforation. We do the 1D MEM and then we find out that which zone is a lower stress zone. We do the perforation in the lower stress region and then we perform the hydraulic fracturing job on that zone. Once it's done, we will leave the sand slug in the tail end. We need to wait for the sand slug to settle down and then we need wired line or slick line to tag the plug to see that the plug is covering the initial perforation set that we have just fracked. Once it's done and we had make sure it's tagged, sand slug is tagged, and we are sure that our perforation set is covered with the sand, we will start pumping. We will do the perforation for second zone and then we will start pumping the hydraulic fracturing for the second zone. But again, there is some lack of efficiency in this one as it's a sand slug. It depends on the pressures, breakdown pressures of the second formation, and so. But that's how it is, and this is one of the method that is being used historically in Pakistan to frack the newly drilled wells, which is going well, and the production and the clients are happy with the production side that they are getting. So that's how we are initially doing this hydraulic fracturing in the multiple zone. But again, this have the limitations. This could be done in only a new wells. If it's an old well and it's already producing with multiple zones, then there is a limitation that we cannot do, because if you start pumping when multiple zones are open, you will be pumping the fluid in both the zones. And again, as we talked initially, that we won't have any control in that case without some type of completion or some type of mechanism in place. It could be mechanical or it could be chemical. So we need to have something to stimulate the multiple zones. Again, we have a number of wells which are already in production. Their production have been declined, or somehow we need to have something in place that. And again, there are the limitations of budget as well for the operators, and they need to have the refrag options without the need of bringing the workover rig. Maybe the well is not designed when the completion was done or when the well was drilled earlier. It might not be the case that we will do the hydraulic fracturing in future, and so the completion or other stuff are not favorable in our condition. So we need to have a technique in place that needs to be compliant with most of the things, and which could help us and the operator as well in achieving their objective. So we have introduced a composite pill with it's basically a combination of degradable particles and fibers. It's engineered composite pill, so it have a tetramodal size distribution. So this size distribution is basically consists of a degradable particles with the combination of fibers. So again, we have multiple diversion stuff in place and in use, but this is one of the efficient technique that Schlumberger is using. This have due to the tetramodal structure and the different size of the particles. So what happens is that large particles are basically intercepted at the entrance of the fracture, while the smaller particle reduce the permeability of the fracture, and they basically give us the temporary isolation from that fracture zone where we will pump this degradable pill. The fibers in this combination basically ensure the integrity of the blend, and then when we are pumping, it's enhanced the bridging mechanism that we have. Moving forward, let's talk about this the value that this diversion technique is basically creating. So as we have already discussed this tetramodal structure, larger how larger particles are doing it, and then smaller particles. In my next slide, I will show a video of how basically it plug and provide the temporary isolation in case of multiple perforation network. So the good thing about this pill is that it's degradable. We have both fully degradable and partially degradable stuff in this one. It depends and varies well to well and reservoir to reservoir. What is the main objective of the temporary isolation or diversion that we require, and we basically look into this case by case. So the advantages of this one is that a very small amount of material, 50 to 100 pounds, is required to make this pill. This pill is made with a gel that we normally use to do the hydraulic fracturing and to carry the propellant. The another good thing is that we don't need any workover stuff in this one. This could be performed rigless. The particles and the material that is being used fully degrade or partially degrade depending on our choice of pill that we have used. And once you start the production of the well, it will automatically dissolve, and there will be no residue as well in this composite pill. So let's assume again the same well, the vertical well that we have already discussed, which we are doing it, which we are normally doing it by sand slugs. Let's have a vertical well with two reservoir sections and two perforations in place. So assuming that we are doing the first stage of hydraulic fracturing in upper zone, and then we'll pump at the end of the treatment, we'll pump the broadband pill. So basically, once the broadband pill will reach this perforation, it will block it. So we can see this in this video as well. So initially, we create the fracture in the lower stress region, and then at the end of this, we will pump the pill. So once we pump the pill, it will start to temporarily isolate that zone, and then we will start the second treatment ahead of that one. Once your second treatment will start, it will reopen the fractures of the higher stress regions, and then you are placing your next stage fracturing treatment. And once we open the well, and once we put the well on production, it will be back to this. It will degrade, and it won't leave any residue or anything. There won't be any issue of that one. Okay. So what value this diversion technique creates? It's basically a unique solution with respect to the operational timeline and the cost. It have a higher operational efficiency compared to the techniques that are already in place, like plug and perf and mechanical barriers. So technically, with the plug and perf, normally we do two-stage hydraulic fracturing in like 48 hours time. So this is I am talking specifically about Pakistan, since we have batch mixing facility here for hydraulic fracturing. So that's how it is. And then this technique saves the cost of the workover rig and other services for the operator. We will discuss about one of the case study specifically for Pakistan, where we have pumped this and we have gained 60% production increment using this technique. Again, this is a fit for purpose technology which could be used to stimulate different perforation set. It could be used to do old fragged well as well. We can do the refrag, and it won't leave any residue after the degradation. There won't be any issue of residues or something which is creating damage for the production. Let's see how this composite pill is different from the other pills that we have. So this is basically a lab test of a traditional diverter. So somehow the efficiency of traditional diverter is not comparable to the composite pill that we have in this one with a partial or full degradation. So here we can see how a traditional diverter will work. Somehow there will be some leakage or some. Okay, so this is basically our composite pill that we are talking about. So we can clearly see the efficiency of this material, of this composite pill, how it blocks because of its tetramodal structure, how the particles, the large and small particles rearrange themselves, and then they provide the diversion effectively. Let me finally talk about a case study, one of the case of Pakistan of a vertical well with two stages. So basically, we performed a two-stage fracturing job with a convention in a conventional vertical well, which is completed with 7-inch liner, 3.5-inch tubing, and normal sandstone formation. So one of the formation is already fracked, and we did a refrag on that one. And for the other zone, the operator wants to have basically a connection with the fracture network. So we did a two-stage fracturing job without the need of any workover, and with this composite pill, we can see that here in between the two stages, we have placed the composite pill, and we can see the diversion that we achieve, and then we start pumping the second stage treatment in this one. So that's how it works, and this was the implementation of this technique in Pakistan, and it proved successful, and the operator have gained more than 60% increment of production in this well from both these zones. Thank you. That's all from my side. If you have any questions, we can open them.
Okay, Haris, thank you so much for the presentation, and it was very, very good, very informative, and it was a learning opportunity for us as well. So we do have a hand raised for a question. So Bilal sir, go ahead.
Thank you, Fazan. Haris, my question is like I have been listening to your presentation. Probably, if I have not missed what you were explaining, so basically you convinced us that basically the two systems. One was the multi packers, in which you will be using those hydraulic balls to isolate, and the second one is the pill, right? So the cost saving advantage which you were explaining will be associated with the packers, the assembly of the packers and the ball size in which we are going to have selective fracturing, right?
So Bilal sir, again, so here we have discussed basically different completion techniques, and I mean we have compared all of them, but I mean, I cannot say which one is the best one. This depends on the reservoir and the well condition. This will vary well to well. Basically, we are learning different.
Sorry. I think I was unable to convey my question clearly. So basically, these are two different techniques, right? The pill strategy, which is synthetic pill, and the multi-packer method.
Correct.
Okay.
It could be used together, but it's different. Yeah, but here we are not talking about the hybrid stuff.
Okay. And secondly, when you were giving us the advantages, you only provided the advantage for the multi-packer technique, right?
No. I have talked about benefits of all three, and then we have seen this table as well, comparing all the three techniques that we have used apart from the chemical diversion.
Okay. And do you have any data on the degradation of this the chemical pill which you were talking about? Because you showed us a very nice video for blocking the way from that syringe, probably showing how fractures are going to be not taking the fluid anymore. But what about the degradation? Because some of the times in our practical experience we have seen that in gas wells, we had some diverters when we were using stimulation in carbonates. So we had Schlumberger patented diverters which were not working very well in gas wells. They were working good in oil wells when during the flow back those get degraded, but in pure gas producing wells, we have seen sometimes that diverters are not flowing back or not degrading and compromise production in that scenario. So you haven't talked about, you mentioned in your presentation the degradation, but can you further elaborate the mechanism that how this synthetic material is going to degrade itself after pumping?
Thank you, Bilal Sahab. This is a very good question, and I was expecting this question to be there. Obviously, without the degradation, we cannot talk about this pill. This is one of the very important phenomena of this one. So basically, the degradation of this pill is in contact with the hydrocarbon. Once this degradable material comes in contact with the hydrocarbon, it will degrade. And again, talking about the time of degradation, this will depend and it will vary. So basically, we have a vast portfolio. If we talk about us as a Shrambarji, we have a vast portfolio of different type of composite pill, which will vary. So we have, I have talked, we have fully degradable and we have partially degradable. It depends on the case to case and it varies. So in Pakistan, we have so far used fully degradable pill at a temperature of 220 Fahrenheit. So it varies with the reservoir conditions, with the hydrocarbon and all that. That what we need to show. And again, we have the lab test as well in place to see to show the degradation and how many hours it will take. Because in this one there is also a specific time. After that time, more than 16 hours or something, this material will automatically degrade and you won't get that isolation that you will be getting in that initial 16 hours. So again, we have a vast portfolio of materials. It depends which material we are going to use and what temperature and reservoir conditions we have. I hope I'm able to answer your question.
Thank you. Matlab, we have to, depending on the well fluid and well conditions, we have to decide which kind of diverter we are going to use chemically.
Yeah, temperature, pressures, and all that, and the reservoir conditions. We need to decide which pill material that we are going to use in
But
that
you are
case.
sure that this works in gas wells as well? Are you sure about it?
Yes, we have pumped it in a gas well and a condensate well. So
No,
it works.
you have done it in a dry gas well.
Not a dry gas, a condensate actually.
In condensate, still we have some oil, but have
I'm
you ever
sure
tried
that-
it in a dry gas reservoir? Because in Pakistan, you know that most of the reservoirs are dry gas.
We haven't done it in Pakistan, but I'm sure we must have the case history from around the globe somewhere where we can look in that one.
Okay. Thank you.
Okay, we have another question. Khalid sir, sorry for keeping you waiting for a very long time. I missed you in the first instance. So let's, please go ahead.
Thank you very much, Fahad sahab. Haris, that was a very good presentation. So could you please go to the slide number 9 or slide number 10, sorry.
Yeah, sure. Plug-in perf?
Yes. So you said that if I wasn't mistaken that that you are going to perforate the stage 1 with the coil tubing. So do we have any option that we perforate this with the wire line as we are going to perforate this? Put a plug with the coil tubing.
So basically, this one is a normal phenomena that is being used in industry. What I am talking about. Normally, we do it with a coil tubing. We just do the perforation with the coil tubing, and then we bring the wire line and we do it. So this is just for the understanding of the plug and perf technique. That how we are normally doing it.
But instead, yes, but instead we can. We are not going to pull out the coil tubing while all these stages, or we need to pull out the.
No. The coil tubing will be out after the perforation, and then we have to rig in the wire line. So this is basically what I am talking about. That in this plug and perf technique, we need to use 3 product lines: pumping unit, hydraulic frac, coil tubing, and wire line. So we can, you can compare as an operator which technique you want to use. So in ball activated, we have only pumping. We don't need coil tubing and wire line. So, and then in coil tubing, we only need coil tubing and pumping unit. We don't have wire line. So it varies. So we are basically trying to compare, but again, for the practical applications, it varies well to well. And again, what are the objectives of the operator?
Okay, thank you. And my second question, if you can take that question as well. So as you said that in the case study, or when you are using this coil tubing actuator system, you said that you need to identify the lowest zone or lowest resistance zone. Okay, but you have perforated, one perforation zone in one stage. So how you what I understand from your discussion that you will be using these pills to temporarily block the first perforation tunnels in order to perform the hydraulic fracturing in the second zone. Is it right?
So I got partially. I mean, I got the question. So I guess you are asking that how I will find out that which zones are taking the fluid.
I just wanted to know that when you are going for a second stage, so you will use the pills to isolate temporary
Correct.
the first, perforation tunnels. So, and in that case, your coil tubing will remain in the, I mean, in the hole.
So okay, let me explain a bit. So we are so here in the plug and perf technique. So initially I have talked about this one that once without the any completion mechanism, when we pump the fluid, we don't have any control on it on that one, and we don't know if like it. Let's assume we have a three-stage perforation in a well. It could be horizontal or vertical, whatever. Let's just assume that we have a well and we have three stages in there. When we start pumping any fluid, so the thing is it will go where it will get the less hindrance, or where it will be have where we have the less stresses or something, or it might be the case that there will be a leak off to all of the formations. So what advantage we are getting with this pill is that we will start pumping. Let's assume that all these three perforations are open, and we want to frag all these three stages. So what we will do is initially we will pump the fluid. Uh, I mean, here we can do the temperature logging after that one. After the we can pump injection stage, and then we do the temperature logging to see that which perforations are taking the most fluid. Again, it varies case to case. In some cases, only one perforation could be taking the most of the fluid. The other two are not. So there could be three cases. So in the other one, two of the perforations are taking the fluid, and the third one is not. The last case could be that all three perforations are taking the fluid. So what we are trying to, what I am trying to explain in this method is that we have a limitation in other combinations in such case to stimulate all these three zones. With this diversion technique or composite pill, what we can do is that we will pump one stage, it will go to the lower stresses region, and we will make sure that by doing the temperature logging to see how our fluid is basically working and how is it going in that fractures. Once it's done, we will pump the pill. Again, we to see that how is the pill working, we might need to pump multiple pills to see this diversion of the pressures that I have shown in my case. Then again, it varies case to case, and how efficient we want the pill to be. It's up to us who are designing the pill to that how much diversion that we need. So that's how the pill mechanism work. If we are talking about this plug and perf, this is very simple case. So this is very specific. When you are doing a stage one, there will be only stage one. So there will be perforation in only stage one. So the frag fluid will not go anywhere else. It will go in the specific stage, and then we will plug it. So it's finished. Now you will have the perforation in the second stage. Your second stage fluid will go in stage 2 only, and then you will plug it. So in the plug and perf, ball activated, and all these systems, there will be no issue of going in other zone or anything like that. Hope it's clear.
Yeah, it's very much clear. But when we are using this diversion technique, it will go in one go. It will save time. If I just got your from your discussion
Yes,
conclusion, yeah.
exactly. It can stimulate multiple zones in one go.
Okay, thank you very much. Thank you, excellent.
Thank you for the question, Khalid Saab. Afra Saab, your turn now. Please go ahead.
Yeah, thank you, Fahad. Haris, can we go back to the last slide of the conclusion you have been showing?
The case history.
No, the last slide.
So last slide was our case history.
In which you are showing this barrel, 18 barrels per minute.
Yeah.
That's right. Okay. So this 18 barrels per minute pumping rate, this is basically a bullheading.
Yes.
Okay. Fine. Okay. My next question is related to this broadband sequence you have utilized. You have presented a case history for Pakistan. I believe that was for a sandstone.
Yes, it's a sandstone.
Okay. So as you have been saying that because this is a branded product of the Shimbaje, so they have they utilized somewhere for the during the acid frac?
So for this is specific broadband sequence is for we haven't. I mean, we have used it apart from Pakistan. Outside the region, we can look for the case histories with the acid frac as well. It could be used. So the pill material will change. As I have talked, there is a vast portfolio of the material that we are using. So this material that we have used could be different in case of acid fracturing, but it will be a composite pill.
Yeah, because my question is related to this acid frac, because if you have used this with the broadband sequence with the acid frac, that's my question. And you said that at the moment you don't have an answer. You can check in your portfolio and then you will be able to answer that. Okay, fine. And my third question is that as we have talked through your presentation, you have said about the about the hydraulic frac. My question is that this broadband sequence, can we use it in the conventional? If we are not, I'm not doing any frac job, but I do want to have a selective stimulation of the sections in a well bore. So can I use this broadband sequence there? Because you are saying it's a small volume, 50 to 100 pounds you will be using, and it can. I'm not sure that whether you have any case history with you that can say that it has been used or it can be used with in the conventional sands or in the conventional limestone reservoir, something like that.
So the answer would be yes, we can use it, and it's not necessary to do the frac. I mean, we can. So basically, the pill is a combination, like I have said, that we will mix this 50 to 100 pounds of material with gel. So we can pump it. I mean, it's a bullheading, so we can do it without the hydraulic fracturing as well to plug the pores or anything. You can use this material anywhere. Like we normally do use fibers for fluid loss.
Can we pump it through with the coil?
For with coil, I don't think we can pump it because this is very thick material, and even with in a vertical well, there is a high risk. We had taken that risk and we have successfully implemented it. But even with a 3.5-inch tubing, there are still issues to pump this because it's very thick slurry. Again, we need to design it or engineer it in that way that we can. But coil tubing, I don't think won't be feasible to pump this material. It would be bullheading.
It will be through bullheading. So at the moment you have pumped it only in the vertical well, but I believe that you have a case history in which it has been pumped bullhead in the horizontal sections.
We have this technique is basically developed for open hole horizontal section.
Okay.
So there is no limitation of this material to be used in cased hole, open hole, horizontal, vertical, whatever.
And this broadband sequence is available in Pakistan.
Yes, specific material is available in Pakistan.
Okay, thank you.
Thank you, Afra for your question. So, Haris, we do have some questions on the chat box as well. So let me read it out for you. So we do have a question from Houston. This is coming from Yazani. Very good presentation. Now the question is, in seventh stage frac job, what is the total time required for all fracs and flowbacks? And then a second part of the question is, what is the technique used to measure flow parameters in each frac zone?
Thank you, Yazdani. So again, this question is, it's not complete. Again, we need to see what technique of frac is being used. It varies with the completion technique that being used in. In Pakistan, we are using the batch mixing stuff. If we have on the fly method, it would be very efficient. It would be very less what we have normally outside regions in which we are doing multiple stage frac job and where there is a high volume of activity. So I cannot, quantify the time in this one. It depends on the technique of hydraulic fracturing and the completion that is being used. Again, and the flowback will be same, and it varies with the reservoir formation as well. Which formation is there for the tight formation? Flowbacks will be longer. For the conventional formation, it will be less time. The second one is which technique is being used to measure the flow meters. So, if I talk about Pakistan, normally we are not using any technique to measure the flow. It's initially the pit, and we are just measuring the pit volume that we have here, which is not very much, in consideration in Pakistan, specifically in our region. Thank you.
Okay, I hope that answers the question. So we have another question from Muhammad Usman. Thanks, very interesting topic for chemical versus mechanical diversion. In terms of cleanup, post-fracturing, which option gives better results?
So regarding the cleanup, Usman, I guess, so I have talked about the degradation of this material. If we use the composite pill in case, so the degradation won't have any residue or anything left for this composite pill that I am talking about. So in terms of cleanup, obviously it will be efficient and it will be easier for us to flow back. Again, it depends on the objectives of the operator, that how long they will take to flow back, and how efficient is the system on the in the well, and how is the techniques and all the placements that we have are in place. So we cannot, quantify here that it depends. It varies well to well. It varies for each well. It will be different, and for different operator it will be different. Thank you.
Okay, I guess that was a very well structured and very well delivered presentation. We would like to thank you from the forum of SVE to Haris and to our distinguished participants as well. A very, very interesting question for a person like me who doesn't have the background of frac. It was good to know the latest technologies, starting from the fundamentals to a little bit of a mid-level discussions. I enjoyed it thoroughly. I hope the participants have gained some knowledge and some learnings, and we can definitely take forward the discussions. If you have any questions, you can always directly contact to myself, to Noor, or to Haris as well. Everyone is more than welcome. If they have any questions or concerns, we would love to answer it, and then we can take the discussions forward. So on this particular note, I would like to thanks again Haris, and thanks again the participant, and thanks to the organizer Noor as well for arranging this extremely wonderful and a learning session for all of us. So I guess we can close it till we meet again. Thank you everyone for joining.